Hello everyone, good morning, good afternoon and good evening. Dear authors and invited guests, this is a technical session 6A and my name is Recha. I'm the moderator of this session. On the behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as we all are aware, we have been facing a new normal situation to overcoming the pandemic. Hence, the conference has been shifted to the hybrid mode. We are very thankful to everyone who present on this platform to go along with us digitally for this conference and making this conference more productive. We hope you will be uh, enjoying the knowledgeful and interactive sessions. Also, there's a special note for all the presenter. There will be given 10 to 12 minutes for presentation and 3 minutes for question answer. After 10 minutes, I will raise a gentle reminder to conclude the presentation. And I request while the presentation is going on, other participant kindly be muted. And there is another request to all the participants that you all stay connected with us till the closing remark. If you have any query and any updates, kindly write it down on in chat box. Just before we get started, I would like to introduce our chair. In this session, we have Samiksha Shukla ma'am. She is an experienced and focused teacher, always keen to promote the education and well-being of students, passionate about the innovation and good practice in teaching, always engaged in continuous learning to broaden knowledge, currently heading a department of data science, Christ deemed to be University Pune, along with this mentoring AI and healthcare project in association with a professor with Stanford University, core expertise in computational security, artificial intelligence, and healthcare domain. Welcome to you, ma'am.
Thank you.
Now we have start with papers. Now we can call our first presenter, presenting his paper on e-managing the pre-election message during the 2021 parliamentary campaigning in Bulgaria. I think first presenter is absent. So we can move forward to another presenter. We can call our next presenter to presenting his paper on advanced processing and classification on plant disease. Dear presenter, please, you may please start your presentation.
Whether presenters present or not?
A presenter is present.
I think she need to unmute herself.
Yes, she need to unmute herself. Yes, ma'am.
And it will be good if a presenter can switch on camera during presentation.
Can you hear me?
Yes, yes.
Okay. I think my PowerPoint can be seen.
Yes, yes.
Okay. Okay. I think there was some wrong thing with the unmuting. All right.
Could you please switch on your camera?
Wait 1 minute. Yeah. Can you see me? I mean,
yes,
I don't know whether. Okay. I'm Sufala Shaga Silva, and I'll be speaking on advanced processing and classification of chili plant disease. My co-authors are Dr. V.S. Malimat and Dr. Minakshi Sundaram. The contents of this paper are, I'll be going about with an abstract, introduction, literature review, proposed system, conclusion, and reference. Disease identification is a process of recognizing the disease and infected chili leaf images. Then techniques are used to extract the infected part of the image, that is to separate the region of interest from the background. So segmented part is then recognized depending upon what type of disease that it has. So you actually map the feature descriptors of the image. And this type of applications can be used in plant disease detection, object recognition, fall detection, etc. I'll be using in plant disease detection. We know agriculture is a backbone of Indian economy. It definitely needs to grow, evolve in practices. So recognition and detection of disease in plant becomes a very necessary need. Necessary to extract the infection of interest in diseased G4 variety of chili plants, which I'm going to consider. And the disease identification is done using identification method. It is categorized into 5 classes. Main steps are detection, descriptor stage, and then matching stage. Just a little literature review. Sachin K. Karade and Patel proposed a plant disease detection using image processing. They had used, the detection was based on the leaves, stem, and fruit. They had used an AN network. And our proposed work is also similar, a little bit more accurate because we're using convolutional neural network, has a higher accuracy as compared to theirs, which was 88. The regular proposed process is first data collection. You collect the number of images, large number of images, infected images belonging to different classes, then split the data into testing and training. Of course, label the data depending upon what type of class it belongs to. I have taken 4 classes here. Then after labeling, then you configure the model, whichever model you want, then train the model. Then to test the model, you use the testing data and check whether there is a comparative match to classify the different diseases. So data collection, we had collected images which belong to whitefly, yellowing, curled, and healthy. And the data that we collected was a total of 7464 images, out of which training data we took 6,000, testing data we took 1,464. And these, of course, are the bounding boxes. Then we label them according to the classes. And then we gave it to the convolutional neural networks. There are 4 networks that we took into consideration. And the feature map was extracted. And these are the 4 networks that we dealt with: faster RCNN inception model, faster RCNN ResNet 50 model, and single shot multi-box detector and YOLO version 3. For image acquisition, we collected images of infected and healthy leaves of G4 spices of chili, and then we categorized them of the different classes that they belong to was powdery mildew, chili leaf curl, Fusarium wilt, and healthy. Some of them we had captured the videos and then convert them, cut them into frames so as to get a image. And all this we collected from the Central Coastal Agricultural Research Institute, ICAR, which the total data we split them into training and testing. In model design, these networks for designing, these networks usually consist of regional proposed algorithm to generate bounding boxes, location of probable object in the image. In our case, the probable infection in the plant. Then a feature generation stage to obtain features of the object using CNN to extract the features. So a feature map will be generated. The last layers will generate the feature map. Then you need to classify layers to predict which category they belong to. Now, in our case, there are 4 categories. And a regression layer to make the coordinates of the object bounding boxes more precise. Rather, map each input data to real value of the prediction. So for faster RCNN inception model, the configuration was number of 4 classes. We had intersection of union as 0.6, and we used a score converter of softmax. And what we found was a confusion matrix, which is true value against the prediction value. So we got for A would be healthy, B curl, C yellow, D white fly. So we got true positive is 0.79, 0.83 for B, and 0.8. So the values were quite good. So considering that model, image tested by the model which detected class yellow and class white fly. So this image was taken as yellow, and this was taken as white fly with an accuracy of 94 and 81. The model took around 15 to 20 seconds to predict, and the prediction confidence accuracy was 90.90 to 92. So then we took the next model, which was faster RCNN ResNet 50. And same way we configured based on our requirements. Score converter, we put softmax. And the confusion matrix that we got here with the same classification, that is healthy, curl, yellow, and white fly. We got 0.88, 0.87, 0.85, 0.85 for healthy, curl, yellow, and white fly respectively. So looking at this image, which is a white fly, it was considered as white. It detected as white fly with 94%. And the model took around 30 to 40 seconds for prediction of each image with a confidence accuracy of 96%. This model was a little computer intensive, but the CPU usage was similar to the previous one. It has a high accuracy as compared to the inception model, and loss obtained on training was very much less as compared to our ResNet 50 model. And since these both were computer intensive and couldn't be used on a handheld device, which could be like implemented on a phone, we went to other models, that is SSD model and YOLO version 3. SSD model is normally used for real-time. Object detection consists of extracting feature maps, applying convolution filters to detect object, and it uses loss function. The other ones also use loss function, and we use non-maximum suppression. In loss function, it predicts from the positive match. From the positive match should get closer to the ground truth. And non-maximum suppression, the overlapped bounding boxes are deleted, or discard boxes whose intersection of union is greater than the threshold that you have that we have decided on, or discard bounding boxes with the objectness which is less than the threshold objectness that we have decided on. So in this, we found the confusion matrix as this 0.76, 0.75, 0.78, which is much lower than what we had found in the previous models. So when this image was detected, it detected an image as in yellow with an accuracy of around 66. And the prediction time, so prediction time was much faster, was fast compared to faster RCNN model, but the confidence accuracy was very low. CPU usage was less compared to the previous ones. And that's why they said that's why we thought that it wouldn't be very much good for finding diseases. So we go to the next model, which is YOLO version 3, and we configured accordingly. If you see this,
sorry for interrupt, dear presenter. You have last 2 minutes. Please conclude.
Okay. So this is the way we checked. I mean, we found that this was a better one. So if you see these images were taken as healthy yellow and white fly at the percentage of 97, 98, and 99. And it used sigmoid function. The sigmoid function actually gave you to classify a single one into 2 or 3 categories. For performance analysis, we used the regular confusion matrix values, and all these models were compared with each other. So we used all these models to compare, and we found out that the accuracy in YOLO version 3 was much better, which was used for detection of disease. So we put a pictorial view of that. So true positive was much higher for the YOLO version 3, and the accuracy also for YOLO version 3 was much higher in accuracy. So conclusion, various machine learning disease detection techniques were configured and built. YOLO version 3 gave a highest accuracy, and that's why it was more ideal for chili leaf detection, a better model for it. So, and then afterwards, just to put it on an Android phone or iOS phone, we converted into .tifflight format so that it could be used on a regular phone. There are any questions? Thank you.
Thank you. So it was nice presentation, madam. I have few questions. Before that, I would like audience, if they have any question, they can ask.
Hello, yes. I was wondering, so obviously you're planning to use this out in farmers' fields or something like that to identify problem areas. Do you have any geographic or tagging features that you use to mark in the fields that maybe you would come back to this location to see if the treatment has worked for the pests you've identified?
Actually, it was done for a field of that ICAR, that is that coastal area. What is the name? ICAR. And
Agriculture Research Institute.
Yeah, Agriculture Research Institute. And the thing is, not only this is not the only paper. In fact, I checked on every 2 months what was the progress that was given, and based on that, I had another study. So progressively, I have gone through different stages, and we collected different images. So we'll really look through. Not only that, we also checked using some fertilizer, and came to a conclusion of how much of fertilizer that should be used and at what period of time.
Thank you. Yeah, if you have general plans to release an application for general consumer use too, I think that would be something that a lot of plant growers might like. I'm not very, it's a weak point in my own gardening. So. Thank you.
Okay, so anyone else has any question? Okay, so ma'am, I would like to know, there are few models are already existing for plant disease detection.
Yes.
How you can claim your model is better than those existing models?
The existing models have a different combinations of models you use. Like, you use like previous to this, I have also used models where there is classification is different, segmentation is different, or features, extracting the features, different features that you're extracting are different. So based on this combinations, you get a different model. And based on these different models, you can find out whether your model is better or not. Or in this case, how you configure the models. Like there are times when I have there's a paper which I have extracted featured moments, and I just wanted to know whether moments that is based on the moments, the shape of the moment or whatever would make a difference while identifying any of these diseases. So those combinations come up with a different type of a model. Though each one would say that there is an existing model, but then their combination of existing model will be different.
Why have you chosen only 4 classes of disease?
There were at that moment of time when I was checking it out. In fact, I was trying 3 first. And then after that, when I came to I worked with 3 already. And then when I came with another 4, I just added to it. These were the common ones which were there. And to start off with, I thought better start with these ones. And in this chili, that is G4 variety, these were the main ones which the farmers had reported. So I thought I would work with them.
Okay. One more thing, you have used YOLO. YOLO has, I think, V5 also. So why you have chosen YOLO V3?
I had used YOLO 2 before this. So that's how I went to YOLO 3. This was done almost a year back. By the time I wrote the paper and put it up, and took me some time. But yeah, YOLO version 5 has come. I could have incorporated, but I did not.
Okay, I think you can work on it maybe for your
Yes,
next
definitely.
research.
Definitely.
And
Thank
what
you.
I have not seen your paper as such, but it will be good if you can add comparative studies so that we will have a clear picture that, okay, so that this was this existing work and how you have come to this conclusion, or how your model is better than the previous models.
Okay, I have just done a comparative study of these.
Huh.
But otherwise, I have done a comparative study of the other combinations also. In fact, today morning, I gave a presentation on to another conference.
Okay, thank you. It was nice presentation.
Yeah, thank you very much.
Thank you, presenter, for a nice presentation. And I would like to call our next presenter to present his paper on transfer learning in a deep reinforcement learning. And the presenter name is Tariqul Islam. I think the presenter is absent. So we can call our next presenter to present his paper on system using profinient communication for improving a laser engraver.
Okay. Thank you. You hear me?
Yes.
Did you hear me?
Yes, we can hear you.
Yes. Okay. Thank you. Thank you. I will share the screen. Okay. Thank you. This paper was done by a team composed by my colleague and friend Milian Badea, who is near me.
Dear presenter, there is only white screen.
Okay. Sorin Moraru, that's me, and my PhD student, Vlad Stefan Petre. I will start with presenting our city, Brașov, in Romania, which is an old cultural city, hosting the first school in Romania, and also is a multinational area. Our university is founded.
Dear presenter, your screen is not visible.
Sorry?
Your screen is not visible. Only white window.
My screen is not seen.
Your presentation is not visible, sir.
Okay, but
it's a white screen.
I shared.
You can
I make share
bottom,
the screen.
share screen button.
Sorry?
Green color button, share screen.
Yes,
at the bottom.
I shared. I already shared.
Sir, you try to share it again. You just close it and try again.
Okay.
You are using PowerPoint presentation, right?
Yes.
So maybe when you click on share button, it will take you to another window. In that you select PowerPoint.
Okay. I understand. Okay. So I will share this.
Yes.
It's better.
Now we can see it.
Okay. Okay. So these are some images from our city. And about university, it's founded in 1948 and hosted a new research institute. The contents, it's presented on the slide, and we will go directly to saying that laser engraving, it's removal of the material from the top surface down to a specified depth using laser. This is an innovation that is being broadly used for part of material and non-metal material preparing. Consists of three main parts: a laser, controller, and the surface. In manufacturing processes, especially in automotive industry, the inscription of the parts with both text or 1D, 2D is very important. This is the old version containing the marking builder, the PLC, and the laser marker linked by Ethernet. The connection between PLC and laser marker was made by a hardware perspective through the control input-output terminal block, the contactor control terminal block, and the MIL connector interfaces. But there are identified several problems. Due to a small number of interface signals, some parts may be non-compliant. The person who selected the program could make mistakes, and some more complex parts containing components received from another supplier. So this could not be done because there is no scanner to read all these codes. Our solution implement solving all these problems, an operator panel, a switch, an electronic key, an IO link master, and a 2D scanner. So the communication could take to receive a response to an order, regardless of whatever it is, confirmation or an error, using this sequence of commands. Because of the laser marker allow reading the program written with the marked string read request command, the first piece is printed with the unmodified laser program. Starting with the second part, after scanning the 2D code, the laser program changes. Another component is, as I mentioned, 2D scanner with Profinet communication that was introduced into the system so that 2D codes could be read and sent to the PLC as a string up to 35 characters. When a reading is completely successful, the scanner sets a value that informs the PLC that a valid code has been transmitted, which is converted from a string to a length of 35. Another component is the RFID system, the purpose being to exclude the possibility of incorrect inscription of a piece. To meet these requirements, for each piece, a net support was 3D printed. This tag has been fixed on each nest, which is programmed with a landmark name. The other component is the electronic key system, which allows the achievement of access levels with different permissions, consisting of a modular adapter in which the token is accessed to be read, and an adapter interface that is mounted in the cabinet. The last component introduced is the operated panel, which allows the visualization of various messages and states, but also the realization of production receipts that are essential in operation of the machine. And the structure is presented in the slide. The inscription cycle starts automatically when the piece is placed in the nest work, as following with the sequence presented in this slide, and 2D code is scanned to extract the desired program, and the inscription cycle starts automatically when the piece is placed in the nest works, as following the sequence presented here. Scanning the 2D code, modifying the laser program, and successfully transferring it is a condition for starting the next registration cycle. And some final conclusions. The modernization was imposed by both aspects related to productivity and elimination of errors. Increasing productivity by changing the landmark involves two simple operations, changing the nest and the receipt. Elimination of unauthorized changes by introduction of the electronic key system. Impossibility of incorrectly loading the inscription program due to the RFID system and working with the receipts. Possibility to modify the laser program for each piece. In this way, there is a possibility that in the case of complex parts, data from the 2D code of the components received from another supplier to be found, and easily diagnosis of the machine through the multitude of the messages and signals displayed on the operator panel using the sensors of the machine, and finally the correct treatment of non-compliant part by evaluating the signals and implementing the scrap box. This is because the reset of these signals is done only by photoelectric sensors of the waste box, so the operator is obliged to put the non-compliant part in this box. Thank you for your attention.
Thank you, sir. Audience, do you have any question? Is there any question? No. Thank you, sir. So I have a question over here. I have like a query rather than a question. Say we use Ethernet for communication. This Profinet is, you are using Profinet, right? Am I correct?
Yes, yes, Profinet is.
You are using Profinet. So what my understanding is, like for interoperability, we prefer Ethernet, but Profinet, we need to have a specific type of communication mechanism. So don't you think the adaptability of proposed model will be less?
Profinet is one communication protocol made by Siemens. In
Yes,
a
sir.
factory where we work with we made this machine. They work only with Siemens PLC, so we can use TCP/IP. I gave you one example, which is a general communication
Protocol.
protocol, but because Siemens use Profinet and all other suppliers, I have one Keyence, which is Japanese firm who made the laser marker and 2D scanner. They implement Profinet like not like an option, come all the time with their product. So was not very complicated to use this communication protocol because a lot of supplier made their component with this protocol inside.
So, so it is now getting compatible.
So all the components are compatible with
Profinet.
IO-Link Master is EFM firm. They gave this master with Profinet. Okay, you can order with Profinet, with TCP/IP, or many type. But because PLC come with Profinet, and is very easy to use all the component with Profinet.
Okay, so what is the main advantage of like why you preferred Profinet over this Ethernet or any other protocol? Like, what is the main advantage of it?
The main advantage is that with Profinet you can read exactly using name of the memory in the PLC. If you use Modbus TCP, I gave one example. You must make a list with registers. So you can read register number 3, and you must know 3 is one number. I don't know, number of parts. But with Profinet, you can read database 3, data word 0, and you can read exactly from program what memory you need or what field you need. So it's more explicit,
faster.
It's more easier for programming using Profinet than one general protocol.
Okay. So, sir, what I have understood is like Profinet is like as it is directly reading and all, it would be faster compared to the Ethernet.
Oh no, it's like other protocols, and switch is 10/100 megahertz, so is not higher or lower, is the same, but possibility to read direct the field from memories is more easier, and a lot of function system function you can use direct from Siemens, and you can make a complex job using some function, some route from Siemens for one job.
Okay, thank you.
But about speed is the same. About speed is the same like TCP/IP or other.
Okay, thank you, sir.
Thank you, dear presenter. Now I would like to call our next presenter. It's to presenting his paper on transfer learning and deep reinforcement learning. The presenter name is Tariq Islam.
Yes, thank you very much. Just sharing my screen. My name is Tariqul Islam. Our paper name is Transfer Learning in Deep Reinforcement Learning. In here, our paper, we see about we are actually using reinforcement learning for their popularity because it is very simple and very powerful result we can get from here. Actually, in this paper, our main focus is we study a number of reinforcement learning algorithms, and then ranging from asynchronous queue learning to deep learning reinforcement. And then we actually focus on the improvements, and they provide standard by reinforcement learning algorithm, as well as the impact of initial studying conditions. We can perform analysis of performance by the reinforcement learning as well. And our actually paper main keywords is deep learning and CNN and Q networks and transfer learning. And if we see our main introduction, so that is actually reinforcement learning in a class of machine learning algorithm that is actually from designed for our deep learning model, and it is actually different techniques from reinforcement learning. One of the most popular also we can use in Q learning, where is an agent develops a policy that actually choose that action that is mostly established the lead the greatest total for future rewards. That is also, and we can lastly say we can define shade interesting class learning of that. And if we see our proposed methodology, that is we can mainly approach, and our experiments is we describe here, that is for high number of independent experiments, we actually use a distributed high thoughtful computing resource like as CSTC, that is for equidistant size and space. It is actually initial conditions. And if we see next, our actually main baseline performance of the DQN agent, that is for y-axis. Actually, our x-axis shows the iterations has passed when the agent was saved, and our y-axis y-axis actually for winning percentage. Our next figure actually shows for comparisons of time, the comparison time for also DQ agents. And we can actually here give some description about these pictures and the performance. Actually, the main as we can get a result, the transfer learning shows the potential for the convolution rate, and transfer learning is already seen a great successful in reinforcement learning. And our actually main future works for we improvement for lots of our actually main use for that actually playing two players game, and we actually build some other multiple models for that. Thank you for everyone, and I'm sorry for my background music that is loud. Thank you very much.
Thank you. So I have a few questions. Before that, audience, you have any question over here?
Hi, I take it that you were using the OpenAI gem. You mentioned the frozen lake experiment. What exactly was the asynchronous part of the Q learning that was going on there? If you could elaborate.
I can understand.
Uh,
Where you were using the frozen lake environment, right, from OpenAI, Jim?
Actually, we can use asynchronous for actually our transfer learning.
Thank you.
See, I was also observing that you were talking about Q learning. Can you talk about Q learning in detail?
Yes, sure. Actually, in this paper, actually, we using Q learning for actually subsite. Actually, we know about our Q learning that is actually for action, give action in particular state. Actually, main work for Q learning is particular state of action. But we can use that as a subset of reinforcement learning algorithm for more learn the value.
Actually, see, the thing is, when we talk about transfer learning, you are transferring the learning, like knowledge from one model to other model. That is what it is, right? And with your presentation, I'm not convinced actually. And the model which you have built also is not clear to me. The flow, the steps of the model is not presented properly. So I am also I'm finding difficult to understand what exactly you have done in your paper. Title is good, but I'm not able to understand what exactly is your contribution and how you can claim that work which you have contributed.
Actually, we work with different co-authors, so we actually contribution more of pupils. I cannot exactly presenting you at good at much, but our paper is actually good and we contribution for
That's
we
what I'm
develop.
telling. Your topic is good, but with the presentation, I'm not able to make out exactly what you have written in your paper because I don't have copy of paper with me, and the presentation is not. I'm not able to get convinced with the presentation.
What work is done in there, that cannot be, it's not very clear
Yeah, exactly.
what is done in it. What is the research work you have done in that is not clear. The base of
Even
it is
yeah,
quite is okay, but we don't know what is done by you in that.
even the result and discussion section, I think missing. Can you go to slide number 4 in your presentation?
Sure. Yes. Did you see that?
I think you have not yet shared. Slide number 4.
For actually we 4 or 5.
You have written keywords. Okay, fine. I was thinking if I missed that flow of the protocol which you might have used. Okay, thank you.
Thank you so much, Tarikul. And now I would like to invite our next presenter to present his paper on design and development of a mobile outdoor AR application for on-site visualizing of wind turbines, sorry.
Yeah, hi everyone. Can you hear me?
Yes.
Okay, thanks. I'm trying to share my presentation. Just one moment. Right. So hello everyone, and welcome to my talk here. I'm Simon Burkhardt from the University of Applied Sciences, HTW Berlin in Germany. And I'd like to quickly talk about our work here about the development of a mobile outdoor augmented reality application for the visualization of wind turbines in the landscape on site. So for those of you who are not maybe familiar with the term of augmented reality, basically the main idea of augmented reality is that you add virtual content, virtual models directly on top of your camera screen of your mobile device in order to augment your environment. And so in our case, we added wind turbines in the landscape to get an impression of how it's going to look like in the actual scenery. So in this context now, in the next few minutes, I'd like to quickly present the motivation of why we built this application and also the requirements that we discussed with our target user group, and also maybe say some words about the technical architecture of our work. Well, in many countries worldwide, the construction of new wind turbines is one solution to produce renewable energy in order to fulfill climate protection goals. However, due to the large structure of such turbines, of such buildings, there's a relatively large visual impact on the landscape aesthetics and the scenery. So this leads often to rather negative attitude of the local population towards the planning of new wind turbines. And however, the effects or the visual effects and impacts of new wind turbines often remain unclear for non-experts, and therefore realistic visualizations are very important. So it's very important to see in advance maybe how such new planned wind turbines are going to look like in the scenery. And this technology of augmented reality offers basically the opportunity to see such visualizations on site. As I said, the basic idea of AR is that virtual models are superimposed onto the camera image. Our goal therefore was to build a mobile application to provide realistic visualization of the visual impact of new wind turbines. And in order to find out how such application has to look like, we did several workshops and several discussions and talks with target user groups, and we could find out several requirements of how the functionalities of this application have to look like and how the design of the app has to look like. And I have just listed here some of these requirements that we found out. For example, regarding the visualization itself, of course, it's necessary that we have precise and correct visualization of the turbine as a 3D model. We wanted to have it animated, like the animated rotor movements. We wanted to add additional information onto the camera image, like metadata of the planned wind turbine, the height and the model and so on. Also, we wanted to add functions to manipulate the appearance and the location of the wind turbine so that the user has the option to modify the scaling and the location, of course, and the orientation of this planned wind turbine. Also, we wanted to add functions to store and to import and export functions to store your current view and video recording and so on. And of course, last but not least, we wanted to make it available on common hardware, like on commercially available smartphones and tablets, without having the need to have special hardware with special sensors and so on. And here you can see an overview of the graphical user interface that we developed to realize all these essential functional requirements. Well, maybe let's say before you can actually place wind turbines in your camera view, in the augmented reality view, there's one essential step you have to fulfill before, and this is what we call AR calibration. Maybe just some quick words about this. So one key requirement to have precise augmented reality visualization is that you can determine your orientation and the position of your mobile device very precisely. And this is not possible with the common sensors like GPS and digital compass included, and therefore we need to add an additional calibration. And for this purpose, we developed our own user-aided geospatial calibration. And the idea here is that we display geospatial 3D models like surface models and terrain models onto the camera view, and then we guide the user, or we ask the user to align these virtual landscape models with the actual environment via touch gesture. So the user can then just drag and shift these virtual representation of the landscape in order to fit the actual camera image, and then the user can confirm this calibration, and this leads to a correction or to a correct determination of the global device position and orientation. So maybe just some more words about the general architecture of this application. So it consists of three main components. We have the client, the mobile client itself. We have a server-based component like a content management system, and we have a pre-processing pipeline for the geospatial data. So this pre-processing pipeline is necessary because the geospatial data that we use here for this calibration process, like surface models, terrain models, city models, and so on, is initially not suitable for performant integration into the augmented reality view. So it's not suitable for usage in our mobile client. So we have to convert it to suitable formats, 3D formats, and into small scale 3D mesh tiles. And together, like this data is stored in a server-based component and content management system together with other application-specific data, and can be accessed then by the mobile client. And in the client, we have like application-specific functionality, like for realizing the user interface and so on. And we have a library to provide the actual augmented reality core functions. For example, the calibration, as I just mentioned, and other core features regarding this geospatial outdoor augmented reality. Yeah, right. So we implemented this application based on Android to build a small prototype that we could evaluate and test out in the field. So we used Android together with augmented reality SDK provided by Google called AR Core, and OpenGL-based renderings for all this 3D rendering stuff here. And well, the geospatial processing is done mainly via, let's say, self-made Python scripts to convert or to generate these small scale 3D mesh tiles that you can see here also. And yeah, maybe I just show here a quick video of how this application looks like in the field. So here you can see now the integration of these geospatial models. I just pause here maybe for a bit. So you see here a surface model that is integrated in the augmented reality view, and that the user can then like align with the actual landscape. So maybe let's just repeat this because it was very fast. So the user can just shift it a bit in order to fit the view, like you see here, and then it can be confirmed, and then the camera and the device is calibrated, and the wind turbines are on the correct position in the landscape. And after this calibration, the user can add more wind turbines and more models on this map view here. So you use a traditional map in order to place wind turbines on a specific geographic position, for example. And then it's directly displayed here in this augmented reality view. And you can also like select single wind turbines and change the appearance. Like here you can rotate them and scale them. Here you see again this calibration step at another position. And here another 3 more visualizations here. Right. All right, so to sum up all this presentation, well, I think we could show that we could implement, or we could realize some realistic visualization of planned wind turbines with this developed application that can also handle occlusion in a realistic way, and also can implement precise positioning via this manual calibration step. So I think this demo application can also show the general potential of this augmented reality technology as a realistic and flexible visualization technique on site. And in the initial tests that we conducted in the field, we also received relatively positive feedback. However, we also noticed that this calibration step, this manual calibration step, is not always as easy to use as we hoped for, maybe. So especially by inexperienced users, it's still sometimes a bit difficult to calibrate the camera in this way. So we want to do some more user evaluation here, and to implement maybe also some more optimization to make it like more usable with better usability. And also in our like demo application, we just covered a very small scale area. And if you want to use this on very large scale areas, you have to have large IT infrastructure also, because you have to handle large amounts of data for integrating these, let's say, very complex surface and terrain models. And also we plan to transfer this approach to other application fields, like, for example, to visualize photovoltaic plants or power lines or bridges or large buildings and so on. So I hope I could get you a small impression of our work, and thanks for your attention, and please let me know if you have any questions.
Thank you. It was a nice presentation. Audience, do you have any question?
Hello. Yes, I very much enjoyed the presentation. I was wondering how close I could place the wind turbine. So for instance, if the farmer across the street from me wants to sell his field to a wind turbine place, and the turbine is going to be like within 600 meters of my house, would I be able to experience what life would be like with the new turbine?
Yeah, right. So thanks. Exactly, that's the use case actually. So like farmers or other like local people living in an area where some new wind turbines are planned, they should be able to place them at the exact position. And you can also, of course, place them like 50 meters in front of you. Then you won't see as much because you have to look to the sky to see all of it. But there's no restriction actually of like no technical restriction where you can place them. However, of course, there are like regulations by the state or so that you can't place wind turbines like directly next to your house or so, but they depend, of course, in the country where you live, I guess. And this is also something that you could implement in the application, that you add some non-permitted areas maybe where you can't place wind turbines, but there's no technical reason that you can't display them directly in front of you.
Thank you very much for that answer. Yeah, this is an active, the city area I live in right now is arguing quite a lot over this right now. And actually the people who are arguing is that grape farmers are upset that it will affect the sunlight falling on their crops. And they're upset at their neighbors, but all of the farmers have all of these concerns all the time. So I think the local government has to sort that out really, but.
Yeah, right. I mean, it's also a big issue here in Germany, and that's also what we are currently dealing with in our current research project, where we want to find out like how we can use this tool practically, like in the planning process of wind turbines, that you can integrate like the local population directly, that they can see how it's going to look like, and that they are maybe not so afraid anymore of them, because they get a realistic view. Yeah.
Could you please go on slide number 2?
Yes. This one?
Yeah. So I was thinking, what is this target user group? So uncertain resident as a main target group, because
Yeah.
even I had similar question that what could be the impacts which wind turbine may have on citizen.
Yeah, right. I mean, this is the main target group that we identified in our discussions and talks. So it's mainly meant for people, for local residents living in an area like on the countryside, where some new wind turbines are planned. And they are usually afraid of them because they fear that new wind turbines are going to destroy the landscape and the aesthetics of the landscape. And therefore, we want to provide them a tool to see, like, to get an objective and a realistic view of how they're really going to look like. Because often they are, you see like some faked photo montages, for example, that like some unrealistic simulations of where the wind turbines are looking way too big and not realistic at all. And the local residents are then often afraid of the new plannings. And by getting them like this tool, or by having them to use this tool, they maybe are like get a better impression. And of course, you can use this tool also in other user groups, like for in engineering offices, when you are, or like in let's say in the administration also, if you have if you want to, if you have to, like in the entire planning process, there are lots of steps where you have to provide visualizations of how it's going to look like. Is it destroying the landscape or not? Is it and so on. So, but this is actually the main target group.
You have collected this geospatial data. From which place you have collected this data?
So in our work here, we can collect them from the what's it called in English? I think it's called surveying offices, like some offices of the states here in Germany that provide them usually as open data. So I guess it depends a lot on the state where you live in, whether this data is available or not, and whether this data is openly available or whether you have to pay for such data or not. So in our case, we can just get them as open data for downloading in Germany.
Okay. Okay, thank you. It was nice presentation.
Thank you.
Now we can call our last presenter, and this was last presentation of the session. To present his paper on analysis of outdoor localization using Bacon for the visually impaired, systematic literature review.
Hello, everyone. Can you see?
Yes.
Okay. Hello. My name is Michel Cabañas Carbonell. I'm present the paper entitled Analysis of Indoor Localization Using Beacons for the Visual Impedance Systematic Literature Review. Outline, Introduction, Methodology, Results, Discussions, and Conclusions. Introductions. Currently, people with visual impairments difficulty moving around the world have few opportunities that tutor limits participation, the effects of which results in situation of exclusions. In this context, it is important to investigate the situations of these people, since their development when moving in close place with obstacles considerably compromised to accidents causing into disease to no carry or their daily activities. Therefore, it is intended to know the use of IoT technologies for indoor locations to facilitate the proper control, monitoring, and displacements of visual impairments peoples and prevents their activities and preventing accidents when moving in their details life. Methodology. In this paper, research question 1 What are the best indoor locations systems for the visual impairments? Research question 2. What technology can be used to monitor and control visual impairments people to improve their movement in enclosed space? Research question 3. How does a positronic system influence visual impairments people to improve their movement in enclosed space? In this paper, the criteria inclusion and exclusion is can see table 1. Inclusion 1 article relies to systematic review of the model in beacon predictions. Inclusion 2 article relies to the development and comparison of NCD predictions model risk factors. Inclusion 3 article relies to the implementation of location model for beacon predictions. Inclusion 4 medical article relies to beacons. Exclusion are not inclusions. The feature 1 inclusion and exclusion stage record identified through database search AT no include and duplicate age record screen 72 dynamic to inclusion criteria 4 study inclusion in quantitative systems meta-analysis 68. The feature 2 database is Scopus, GeoScience, DialNet, ESCOhost, IEEE, Explore. Total 68 paper relevance. Results. The feature 3 total number of article analysis per continent and per year. Can you see the continent Asia, more paper? The table 2 distributions according to the topic of the article analysis, mobile application and technology for indoor mobilization, visualize and impairment peoples, detection system for visualize and impairment persons, 6, implementation of chatbox for indoor positronics, 12, obstacles, prediction through beacons positronics, 6, development of mobiles application, 4, predictize model for indoor positronics, 5, present challenges and advanced and beacon positronic 8, impact of beacon on the population 3, advanced and new findings of beacon 6, characters of the indoor location 4. The table 3 systemizes article of mobile technology for indoor mobile of people with visual impairments. Topic detection system for visual impairments persons, 3 articles, implementations of chatbots for indoor stations, obstacles, predictions, drone beacons, positronics, development of mobile application, predicting mobile for indoor positronics, detection system for visual impairments persons. The table 4 study relies to beacon positronics, topic reset advanced and challenges and beacon positronics, impacts of beacon on the populations, advanced and new finds on beacons, characters on the indoor locations. Can you see studies? Discussions. The question 1, according to feature 3, I can visit that the article relies to our topic use beacon technology, mobile app, IoT, etc. This results indicates that these categories allows us to have a control and monitoring for the movement of people with visual impairments. According to table 2, we can see that categories of article relies to our topic using beacons technology for training and positronics. The result indication that this category is one of the most used to control and track visualize impaired peoples. The question 2, according to feature 4, we can appraise the number of articles related to our topic for age continent between years 2060 to 2021 in mention using technology for monitors. The results indicate that this category of technology allow to use track and monitor people with visual impairments. According to table T3, we can see categories of article related to our topic mobile application and indoor technology for visual impaired people. The mobile application moves the connectors to a matrix and IoT system which allow tracking and control by providing the location of the persons. Question 3, according to table 4, we can see the categories of the article related of topics. Study relates to compositronics. Indoor location system must be connected to a matrix and IoT system, which allow tracking and control provides better displays of people with visual impairments. Conclusions. The topic indoor location system and beacon basis positionings have already been implemented in mobile application and indoor positioning system, which confirms the importance of location system for the displacements of visual impaired peoples. Likewise, the review allows us to answer the question poses as they have as a strategy that use beacons and their implementation to detect the positioning of such people and in turn the importance of IoT to automatic applications. It's recommended of future work on the use beacons, the development of IoT basics applications and system with data and features related to indoor positioning. Thank you.
Thank you. So it was a nice survey which you have conducted. Audience, do you have any question? Okay, so while going through your survey, have you found anything like Beacon's technology, which in which somewhere we can use mobile type of devices rather than a specific hardware to communicate?
Yes, we can see category of article relays or topic mobile application and indoor technology for visual impaired peoples. The mobile application must be connected to a matrix and IoT system which allow tracking and control by providing the location for the person. The connector for matrix IoT.
Apart from this, is there any other technology which is used for smart home solutions, which you feel that could be a better solution?
Yes, a solution detection system for visual impaired persons, implementation of chatbots for indoor positronics, obstacle predictions through beacons positronics, development of mobile application to predictions mobile for indoor positronics, detection system for visual impaired persons.
Okay, thank you.
Thank you.
As we have completed all the presentations, and I sincerely thank our authors and participants for the excellent presentation in this session. And I hope this session was informative enough. All the presenters would be getting digital certificate through email within 2 working days. And further, all the papers has already forwarded to the Springer, and the publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT. And I also thank our session chair for giving us time, and thank you so much, ma'am. This is a token of appreciation on behalf of team ICICT and the Global Knowledge Research Foundation. Thank you so much, ma'am. Your precious time and your valuable time.
Thank you. So it was good to hear from all the authors. Even there were few terms which I was also having more clarity on. And yes, as we started with the plant disease prediction paper, and yes, most of the paper which I have faced over here are really good. There are maybe I think one author was not able to present, and one paper I was not able to get what exactly he is trying to convey. But otherwise, plant disease prediction was a good paper which I really enjoyed listening to. And then Profinet paper also something which can be implemented in future, and it has lot of scope. Thank you all the authors. Thank you, Richa, for inviting me.
Thank you very
Thank you,
much.
ma'am. And I kindly request to all the participants, please turn on their cameras for this virtual conference to making this more memorable. Dear participant, please turn on their cameras. Thank you so much, everyone. Thank you, ma'am.
Thank you.
Stay safe and take care, everyone.